This focus is called the angry liquids. And I'm gonna see before the session is over today, if anybody can figure out why I called it the angry liquids. The problem is, why does the green float on X but the red sink Y? The focus involves 4 liquids: green, red, X, and Y. I'm going to put some of the green in X. I want you to watch what happens.
Whoa. Oh.
It floats. It floats. The green floats on X. Okay,
Oh,
now I'm going to put some of the red in Y, and you'll see that it sinks.
Oh. It's like little bubbles.
Okay, so the problem to be solved is, why does the green float on X and the red sink in Y? Now, do you think it would help to know what the liquids are?
Yes.
Probably, so we'll find out what they are. We're going to start with the green. Does the green contain any blank? Now I'm going to give you a clue about something that's in the green. Here's the green. A substance I put in the green is the substance that we program our planetary space probes to look for when we send them to other planets. What's the main thing that we program our planetary space probes to look for? What? Jonathan?
Rocks.
Huh?
Rocks.
Rocks? No, not rocks. Who knows for sure? Nathan.
Water.
Water.
Oh, ice.
Well, they see a lot of rocks, Jonathan, but I don't think that's the main thing they're looking for. Okay, so the green contains water. Why do we have the space probes look for water? Does anybody know that? Jeremy?
For people who know about different planets.
Well, you're elaborating a little bit. Water is needed for life to exist. If we can find water, then life may be there. And you may or may not know that we have found water on Mars. So now we're programming our Mars probes to look for life, but we haven't found it for sure yet. Okay, who knows the control question for number 1? Raise your hand if you know the control question. Where's your name tag? Okay, Janelle.
Does the red contain water?
Does the red contain any water? Yes. All right. Now, we have to ask this question next. Don't give the answer. I want to call on somebody. Does the green contain blank, 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 blank water? Raise your hand if you know. Well, I'm going to have you vote. Raise your hand if you think the green contains only water. How do you know it doesn't contain only water? How do you know, Allie?
Because it's green.
Because it's green. If your water comes out of your water tap that color, you better call the health department right away. All right?
That means Martians are
Only water. No. Who knows the control question for number 3? Control. Darby.
Does the red contain only water?
Does the red contain only water? No. Okay, so that means there's something else in the red and the green. Does the green contain any blank? Yes. All right. If you are almost sure you know something that's in the green besides water, raise your hand. Chase. Yes, food color. Who knows the control question for number 5, or control for 5, Stevie?
Does the red contain any food coloring?
Does the red contain any food coloring? Yes. All right, now we have to ask this question. 7, does the green contain blank, 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 blank food coloring and water? Raise your hand if you're somebody I haven't called on yet and you know what word goes in the 4 blanks. Brandon.
Only?
Only food coloring and water. Yes. All right, now raise your hand if you're somebody I haven't called on and you know the control question for 7. Tanner.
Does the red contain only food coloring and water?
Okay. Yes. Well, they both contain only food coloring and water. But the green floats and the red sinks. Now, one possible explanation for that is that possibly the red food coloring is more dense than the green food coloring, because you should know, because of what we studied in other focuses, that more dense things sink and less dense things float. So maybe the red food coloring is more dense than the green food coloring. What experiment can we do with the liquids to find out if it's the food coloring that's making the difference? What's the experiment, Emily?
You can put the red in X and the green in Y.
That calls for 2 experimentation questions. Raise your hand if you know what word an experimentation question always begins with. What word does it always begin with? Marley?
I think I know what stuff is that you put in there.
Well, but do you know what word an experimentation question always begins with?
Does?
No. Emily?
Yes.
Yeah. Where are we about? 9? Okay. If you put the red in X, will it float? And then the other experimentation question is, if you put the green in Y, will it sink? Well, anytime you ask an experimentation question that I can actually do, I'll do it. So watch what happens now. I'm going to put the red in X. Does it float?
Yes. Yeah.
Okay, it floats. Now I'm going to put the green in Y. Does it sink?
Yeah.
Yes. Okay, the answer to both questions is yes. All right. Those 2 experiments prove a couple of different things. Who can name one thing that those 2 experiments prove? Name one. Wyatt.
That it doesn't have to do with the food coloring.
Right. It proves that the food coloring is not different densities. It proves that the food coloring doesn't matter. What does it prove about X and Y? Janelle?
That they're not water, that they have something in it.
Well, who can tell me something else about X and Y besides what she said? Jonathan?
They're different.
X and Y are different. Okay. Well, do you think we ought to find out what X and Y are?
Yes.
Do you think that matters?
Yes.
Probably. Okay. 11 is X blank. Yes. I'm going to give you some clues about X. We already know quite a bit about X. We know it's a clear colorless liquid. It's the one on the bottom. Okay. We also know it's more dense than water. How do we know that it's more dense than water? What tells us that it's more dense than water, Jeremy?
Because the food coloring floats on it.
All right, because X sinks in
Yeah.
water. The green and the red are essentially water because we found out that the food coloring doesn't matter. So the green and the red are essentially water, and X sinks in water, so that means it's more dense. All right? So it's a clear colorless liquid, more dense than water, but I'm going to tilt it. I want you to watch what happens when I tilt it. Tell me what you notice about X compared with the water on top of it when I tilt it. Who can give me an adjective that describes something that X is doing? Well, who can give me an adjective that describes X? What does it look like X is doing, Stevie?
Like gel.
Looks like gel. What's an adjective? Gel's a noun. What's an adjective? What? Who can think of an adjective? Huh? What? What, Allie?
Sticky.
Sticky? Well, you don't know if it's sticky or not. You have to feel it. Harley.
Thick.
Thick. Can you tell that X is thick?
Yeah.
All right. A clear, colorless liquid, more dense than water, and it's thicker than water. All right. Raise your hand if you think you know something that fits the description so far. All 5 of those descriptions. What's something that fits, Chase?
Baking oil.
Baking oil? No, all oils are less dense than water. This is more dense than water. Okay. Who can think of something that fits? Harley?
Soap.
Maybe some kinds of soap. What else fits? Shayla?
Gel.
Some kinds of gel. Name another thing that fits, Brandon.
Shampoo.
Maybe. Jessica?
Conditioner.
Maybe. Okay, look, I'm going to give you another clue. I'm going to tell you a story about X.
Oh.
I grew up during the Depression. I was about your age in the 1930s. And a lot of families didn't have much money to spend during the Depression. My family was very poor. Only the rich people in those days could afford to buy maple syrup for their pancakes.
Oh.
But this X was a lot cheaper and we used it on our pancakes. Does that tell anybody what it is? What?
Carrot syrup?
Well, corn syrup, right? Caro's the brand that most stores have. But most stores also have their own store brand. This is Western Family brand of corn syrup. It's made from corn. They just squeeze the juice out of corn and then they evaporate the water out of it until it gets thick, and that's how they make corn syrup. Okay, so X is corn syrup. Now, you now should know that corn syrup is more dense than water. Why should you know that corn syrup is more dense than water? Why should you know that? Stevie? Thickness has nothing to do with density, Stevie. Why should you know that corn syrup is more dense than water, Emily?
Because water floats.
Because water floats on it. Or it sinks in water is another way of saying that. Okay, now, let's find out what Y is. Is Y blank? Yes. All right, now here's what we know about Y. We know it's a clear, colorless liquid. We know it's less dense than water. How do we know it's less dense than water? Emily?
Because red and green both sink in it.
Okay, who can give me another way to tell that this is less dense than water? Jake. How do we know that Y is less dense than water?
It jiggles around.
No, because it jiggles. That has nothing to do with density. Jeremy. It floats on water. Okay. You should have known from the very first focus that I presented here in September that things that are less dense than water float and things that are more dense than water sink. Okay, so it's a clear, colorless liquid that's less dense than water. Now, Who knows of a group of liquids that all float on water? A general group of liquids that all float on water. Anybody know? Emily?
Oil.
Oil. This is a kind of oil. But it's probably a kind of oil you haven't heard about. Now, you've heard of canola oil probably, and safflower oil, and mazola oil, which is corn oil, and olive oil, and cottonseed oil. Those are all cooking oils. They all come from plants. Cooking oils come from plants. This oil doesn't come from plants. It comes from the ground. Huh? This oil comes from the ground. All right.
I don't know.
This oil comes from crude oil. But you might find that hard to believe because who knows what color crude oil is? Have you seen the videos of the San Francisco oil spill in the last week or so? What color is that crude oil? What color is it, Harley?
It's like goldish brown.
Well, it's black. Black or dark brown, okay? Crude oil is black or dark brown. Well, but crude oil has this in it. Crude oil is a mixture of a lot of valuable substances. That's why crude oil is so expensive. It has in it, some of the things that are in crude oil are gasoline, diesel, kerosene, Vaseline, tar, and this oil, among others. Now, raise your hand if you've ever heard the word refinery. Have you ever heard the word refinery? Does anybody know what they do to crude oil in a refinery? Well, they refine it. But what does that mean? Anybody know what that means? What do you think it means, Harley?
They kind of like clean all the.
No. That's a good guess. No, they separate all of the individual parts out of the oil at a refinery. There's a refinery up at Anacortes, which is the place where you wait for the ferry to the San Juan Islands. Raise your hand if you've ever been to the San Juan Island, Orcas Island, San Juan Island. Okay, if you're waiting for the ferry and you look across the bay, you see this area across the bay that has all of these towers in it. They're different heights. Those towers are part of the refinery at Anacortes. Each one of those towers separates out a different part of the crude oil. They bring the crude oil in on ships out here, and they pipe it into the towers one by one, and in each tower a different substance is separated. So the refinery is for the purpose of separating all the different components of crude oil. Well, so this comes from crude oil. All right? It has this name. There are this many letters in the name of this oil. Now, things that come from the ground usually have this name. Copper ore, silver ore, gold ore. See, tell me, say it when you know it, what kind of oil this is. M-I-N-E-R-A, mineral oil. Why is it called mineral oil? Because it comes from a mine. An oil well is a mine. A gold mine is a mine. A silver mine is a mine. Minerals come from all of those mines. So this is mineral oil. All right. Does anybody know what mineral oil is used for? Do you think you know? What? Mineral oil is not used for cars. Anybody else want to guess? You had your chance. Anybody else want to guess? All right, here's one of the main uses. And here is why I keep a bottle of mineral oil in my medicine cabinet at all times.
Put on a cut.
All right. Here's one of the main uses, and it's why we keep it in our medicine cabinet. If you get a